Hello, my name is Brian Wagner, and today I'll be walking you through my individual course project for the Software Engineering 861 class. The project is called BW Solve Journey Planner, an application that allows users to plan journeys with real-time traffic and weather data. I'll explain the architecture, some of the challenges I faced, the technologies I used to build the app, as well as walk you through a live demo. So let's dive in. The core requirements for this app were clear. First, I would need secure, seamless user authentication. I achieved this by integrating Auth0, which supports both social media logins and email with multi-factor authentication. The app also needed to handle journey management, which includes creating, updating, deleting, and viewing journeys. This was the core functionality of the app. Real-time traffic and weather data had to be integrated, ensuring the user always receives up-to-date information. And for the UI UX, the app had to be responsive and optimized for both mobile and desktop devices. Data security was a critical requirement to ensure the protection of sensitive data. Other success criteria included scalability with auto-scaling, continuous deployment, and error monitoring. Here's the architecture of the app, showing how the front end and back end interact with each other and with third-party services. It was designed to ensure high availability, scalability, and seamless user experience. The front end is a React.js single-page application built with TypeScript using Tailwind CSS for styling. It communicates with the backend through API calls made via Azure API Management, or APIM, and also makes calls to the Google Map API. Then for state management, I'm using Redux Toolkit. The backend is built with Express and Node, providing APIs for journey management. JWT tokens are used to authenticate requests, and the routes are protected by middleware for role-based access control. The backend integrates with Google's geocoding and Routes API for location data and routes calculations respectively, and Visual Crossing's API for real-time weather information. MongoDB Atlas is the cloud database. The app is deployed on Azure with the front end hosted on Azure Static Web App and the backend on Azure App Service. Then application insights in Azure Monitor are used for real-time performance monitoring. One of the major challenges was getting familiar with Node coming from a .NET background. It took me some time just to get up to speed and used to handling asynchronous operations and promises. Configuring the Auth0 for social logins and MFA also presented some complexity, especially with certain authentication flows. I also encountered challenges with testing, especially in setting up Jest for certain mocking scenarios. For opportunities, I do see some exciting ones for future development. For example, could integrate AI-powered features to predict traffic and optimize routes in real time, which could further enhance the user experience. Could also consider adding offline functionality so the app can work in low connectivity areas, which could be useful for drivers on the road. Additionally, I plan to explore serverless architecture or containerized deployments to improve scalability, and which could also potentially reduce operational costs. Implementing infrastructure as code with Terraform would automate the provisioning and ensure environment consistency. Lastly, integrating IoT for real-time driver monitoring could also offer significant improvements, including predictive analytics for maintenance and driving behavior. Okay, so now let's dive into the live demo. So to do that, I'm going to bring up the application. So this is the BW Solve application. I'm going to log in. When I click the login, I'm presented with a few options. I can either log in using email address or password, email address and password, or I could use one of these social media logins, either Google or GitHub. So I'm going to select GitHub here. And for the MFA, it's going to ask me to enter in my one-time code. So I'm going to enter that. So that brings me to the dashboard. So on the dashboard, so this is divided up into or this layout is a master detail layout. But to start, well, on the left here, you can see a list of journeys, and on the right, there's some the details for the journey. But to start here, I'm just going to click the Add Journey button. So I'm going to, for the name of the journey, I'm just going to enter in business meeting in New York. For the driver name, I'm going to put in Jane Anderson. There's a few options for status: scheduled, in progress, completed, canceled. I'll leave the default scheduled. For the original address, I'm going to just put in Philadelphia for PA. And for the destination address, I'm just going to put in New York, New York. And notice if I leave out one of these required fields, some client-side validation is happening, so it's going to prompt me to enter that in. So I'm going to click Save. And so what happens here is when I submit that form, the backend is going to call the Google's geocoding API to convert the address, both the origin and destination address, into latitude and longitude coordinates, which are stored in the Mongo database. So if I come in here into my MongoDB cluster, if I click refresh on the journeys, we could see the new journey created here for the business meeting in New York. I'm going to go back into the dashboard. So as I mentioned here, when I click on here, the details for the journey come up on the right. So you can see the driver name, the status, the origin, destination addresses, as well as the app's making real-time API calls to get traffic and weather data. The weather data is pulled from visual crossing, and that information is displayed here. So this weather reflects the origin address. So this is the weather currently in Philadelphia, USA. So it's partly cloudy here. So I'll also point out that the background for this card, this weather card, reflects the current conditions. So when I clicked on this leadership strategy meeting, so the weather in King of Prussia is actually clear right now. So it's showing this orange yellowish card, but in Philadelphia, PA, it's cloudy. So it's this grayish color. You also see some traffic details here, such as the duration and distance, and that information is pulled from Google's Routes API. The app also integrates with Google Maps to show the route with traffic and marker overlays. So my business meeting in New York, the Philadelphia marker here is this in green, which is the origin, and the destination is this reddish orange marker, and over here for New York. And the duration for this this route is 5,896 minutes and 93 miles. Notice here that there's also, if I change the language, so it will also update the units of measure here to kilometers, and the weather as well. But I'm going to go back to the English. So now let's see what's happening on the, well, briefly, let's show what this looks like in the code. So the code is divided out. So there's the back end. So this is the Express application. And the front end is the React application. So when I'm calling that journey route, it's getting called through here. It's doing some validation with the job, some validation with the body and the request. And then it's going to call this journey controller. So this is the update journey controller call. One thing I'll point out here too is that there's this cache busting. So so if the journey destination or origin addresses are updated, and we want to make sure that we're going to be pulling in, since the traffic and weather is tied to the address, we want to make sure that the app's going to pull down a new copy of the weather and traffic information instead of pulling down that stale cache data. So that's what we're doing here. And finally, it's going to return the journey. I'll also point out the CI/CD pipeline. So there's a front end and back end. So both very similar. So both the front end and back end automate the build, test, and deployment to Azure, the front end to the Azure Static Web App, and the Azure App Service and the GitHub Actions. So now let's go into Azure here real briefly. So I like to point out the resource groups. So these are the different resources. There's an instance of API management. There's app services, the Stack Web App. API management, this is our BW Solve API on the back end, different endpoints. Under the all operations, there's this policy here. There's also an extra layer of validation it's doing. So, so this policy is checking for a valid JOT before allowing requests to reach the backend. So this just adds an extra layer of security, ensuring that only authorized requests can access the backend. There's also this rate limiting policy down here. Finally, let's go over to API management, or I'm sorry, application insights. And if we take a look at the application map, we can see the different services that are being called, the Google, the visual crossing, the auth-o, as well as the service. We can also see the transaction search. So if I pull in the last 30 minutes, we can see all the different calls to the backend service that are being made, to the weather, the traffic, and all the journey ones. Okay, to wrap things up, some of the key achievements of this project: successfully built a React.js SPA with Auth0 integration for secure login, deployed to Azure. The backend was built using Express, deployed to Azure App Service with the JOT token validation, integration with third-party APIs like Google and Visual Crossing for the weather. CI/CD pipelines were set up using GitHub Actions to automate build, test, and deployment processes, ensuring continuous delivery. Looking ahead, I see some exciting opportunities for future enhancements. AI-powered features, offline functionality, serverless architecture, and even potentially IoT integration for real-time driver analytics. So that concludes my walkthrough of the project. I want to thank you for your attention, and please feel free to reach out to me if you have any questions or feedback. Thank you.